This video is going to give you a complete beginner's guide to AI RAG in your business. It's going to tell you what it is, why it's useful for your business, and the alternatives. And it's going to be the only video that you need to learn about AI RAG and what it means for your business. If you want to learn more about implementing AI within your business, then head to school.com/scrapes, where I teach nearly 500 business owners how to implement AI step by step within their business. Let's jump straight into it. Retrieval Augmented Generation. So we can split up RAG, Retrieval Augmented Generation, into two parts: the Retrieval Augmented, which we'll cover in a second, and Generation. So I'm sure you're familiar with ChatGPT, and when you talk with ChatGPT, what you're doing is getting a large language model to generate an answer for you. So for example here, whenever you type a query in, you're always hoping that it's going to come back with a good answer. Now, the problem with standard generation is that actually there's two key issues. The first is that it's out of date often. So for example, inside ChatGPT, the general knowledge of the training data only runs up to June 24. And the second thing from a business perspective is that it has no access to source data. So if you were to ask it a question like, tell me about my business growth in Q2 of 2024, you'll know that it doesn't actually have access to your data. So the retrieval augmented part of RAG is actually designed to solve that problem. So the retrieval augmented part means that we can add context to our LLM question to give it that additional information so that it can come up with a contextualized answer. So for example, that might be feeding in our business documentation so that the LLM can use its intelligence and answer based on the context of our business. When you use an LLM with RAG, or Retrieval Augmented Generation, all we're doing is adding that context to the prompt and telling it when it answers our question to refer to that data first. So it always checks that source data before it gives us an answer. So you can see how this enhances the context in which the LLM answers. And it also means we get rid of the two problems. We have a source of data where it can pull information from, and it's completely accurate in terms of date. We can update the data source and our LLM will have access to the latest data. So how do we actually set this up? So there's a few ways we can pass the business context. And we think about it like this. When you type a question into ChatGPT, you've effectively got that initial prompt, which is your user query. But somehow we also need to provide it with that business context. And often that can be pages and pages of data. It could be your customer service training manuals. It could be legal documents. It could be any other source of data that you have in your business. So this can be vast amounts of data. So we have a few options to feed it in to the prompt. And the first is just feeding that data in every time. So imagine you're prompting ChatGPT. You've often gone to another tab where you've got some data that you want to work with and pasted that directly into the prompt with ChatGPT. Now that works for a small amount of data, but what you're doing is feeding in that data every single time. And we know that ChatGPT and LLMs operate on a token basis, and that token window has been increasing over time. So we've got some examples here with GPT 3.5, which was one of the earliest well-known models from OpenAI. And you can see that it had an output token limit and an input token limit of 4,096, which is approximately equal to 3,000 words. So not a huge amount when you want to consider all of the business data that you work with. It's about 6 pages. As models have progressed, you can see that some of the latest models have a much greater token window. For example, GPT-4o has a token window of 96,000 words or 128,000 tokens. But you also pay per token. So per million tokens, you're paying $2.50. So the more data you feed in to every single question, the more it's going to cost you. And when you're working at scale in a business, we obviously want to reduce the number of tokens we're using every single time. So that's where we come to the traditional RAG and CAG. So we'll go through RAG first. So you can think of RAG here like feeding in the data little by little. And you can think of CAG as feeding in the data all at once. But the difference here than what we discussed before is everything is put in a temporary store And you can ask multiple queries and it's only fed in once versus putting the data in every time if we're inserting it directly in the prompt. So in terms of RAG, there are two key stages. We have the ingestion stage, where we're effectively taking our large business documents and we're putting them into a store. And then we've got the retrieval stage, where we're asking our questions into ChatGPT or an LLM, and it's referring to that context from our store and then using that to answer our question. So the ingestion and retrieval. We're going to run now through exactly how that works and what the benefits of using something like RAG are for your business versus something like CAG, where we feed it in all at once. So in the ingestion stage of RAG, we have our large documents, which might be our entire company knowledge base. And the first thing we need to do is split it into logical chunks. And this is what we call chunking. So we're going to come down here to this chunking section, and we're effectively just splitting into fixed size chunks, like 200 to 500 characters, content aware chunks, like paragraphs or subsections of a certain set of documents, or an even more granular chunk, which we call recursive chunking, for documents that are heavily hierarchical. So think about technical manuals, laws, things that have lots and lots of subsections within subsections. We might use this recursive chunking to split it out into its individual sentence lines. For fixed size chunking, it could be that we store our customer service guide in Notion, and we know that roughly one block pertains to a particular FAQ, like how to reset your password, steps to troubleshoot login issues, and we actually just separate it like that. In our content aware chunks, we could have certain separators, like inside a product manual, we could have key headings that we could say, okay, on every heading, split the document. And then we talked a little bit about the legal documents and splitting on every single subsection within a section. But in essence, chunking is just taking large documents and splitting it into manageable chunks so that when we come to retrieve it, we can find it really efficiently and it saves the LLM digging through the whole set of data. So we've got the large documents, we've split them into chunks using one of the methodologies. We then have to store it somehow, which is where we come to vector databases and vectors. Now they sound complicated, but they are actually very simple to understand. So each of these chunks, i.e. this could be a paragraph, it could be a sentence, it could be a section of 500 characters, need to be searchable for our LLM. So that's this index stage. And what we need to do is embed it in a database. So if we scroll down here, we've got an example of what embedding looks like. So in a traditional database, we're able to search for exact matches like man, woman, daughter, son, but we have no relationship between those values in a traditional database. A vector database changes that by representing each of these values in a 3D plane. So you can see on the example here, we've got banana and pear, which are nothing alike in spelling, but similar by meaning, and they would be closer to each other than Apple phone, which semantically means something entirely different, but obviously has the word Apple in. So we call this embedding, where man and woman here, or banana and pear, become a specific vector within our vector database, or this spatial relationship. And they do that by converting them to vector values. So you can see here as an example, we've just got these digit values, which represent characteristics of the input word. This means that when we come to retrieve the context around our business, our query also needs to be embedded using the same embedding model in order to retrieve the data that's most similar to our query, which is exactly what we're doing when we're retrieving the data from our vector database. Now, I won't dwell too much on the embedding models, but there are different embedding models for different use cases. So for example, if you were looking for text similarity, like matching customer questions to FAQ answers, then you might use a model that's particularly good with finding similar text versus other embedding models that are domain specific that have heavier context in certain domains that are particularly complex, like legal or medical texts, you'd need to go to a much more granular level if you were to build a specialized vector database retrieval. And all we need to do as businesses is understand that there are different models and some of them are better for our use case. In something like N8N, which is an AI workflow automation program, which we teach people how to use in the community, they have all of this set up already for you. You just need to select the one you want. So it's actually very, very simple to use. So let's go back up here to RAG. So we've got the large documents, we've split them into logical chunks, and now we've converted those chunks or embedded them as vectors into our vector database, and they're stored in chunks, which means each chunk has a vector position and also has the business context stored with it, which means it's really efficient to search because we're actually just searching by the vector, not by the information itself, but it's then able to pull that information. And one thing I didn't mention here was the ingestion happens once or every time we update the data. So it's a single event process that we continue to update in the vector database. And then when it comes to retrieval, a user asks a question inside the LLM or the ChatGPT interface. Like we mentioned, it converts our query into a vector so that we have a semantically similar vector position. And it then uses that vector position to do a similarity search, which pulls the 5 or 10 or 15, whatever we choose, most relevant bits of information that match the wording in our query. And the important thing here is it's not looking out for particular words, it's understanding the semantic meaning of the words. So that then goes into the vector database, pulls the top most relevant context back, and adds that into our prompt for the LLM. So the LLM is then able to use that top 5, 10, 15, or whatever bits of information and add that context to its answer when it's answering us. So it will give more accurate information than if it were to generate an answer without the context. Now, the benefits of something like RAG is that it's easy to update the business data and it's very scalable. We can make this vector database huge to cover all of our business data. The fact that when we ask a query, we have to go and retrieve that information from a vector database makes it a bit slower in its retrieval. And it's also a bit more complicated to set up because it's got all these steps we outlined in the ingestion and retrieval. Now let's have a quick look at the alternatives or the most popular alternatives. There are still popping up lots of different ways to supplement your prompt with your business data or your context, but CAG or Cache-Augmented Generation is one of the most popular techniques, and I'll tell you exactly why that is. If we go back up to the token limits and costs here, RAG has been really popular since GPT 3.5 came out, because if you think about it, we're feeding this business context back into our prompt. So say we have a prompt that's 100 words long or 50 words. We've then only got 2,900 words left to use in the prompt. So if we did something like CAG where we throw all of our business data in, it wouldn't be able to handle it. It would not be able to handle it. However, as models have advanced, you can see the token limits have vastly increased to the point where Gemini Flash 2.0, for 10 cents per million input tokens, super cheap, allows 1 million input tokens. And I can see this is incorrect here because it's not 6,144 words. It's significantly higher than that. It would be closer to something like 800,000 words based on this. And I believe the average novel is 96,000 words. So 10 times that we can feed into our prompts now for relatively cheap, which is why CAG is becoming more popular. Because, to remind you, CAG is not about feeding in the information little by little. It's about feeding in everything at once. But instead of putting that in every single time into the prompt, all of our business data, all of the documents copy pasted into our prompt every time, it caches it or it stores it temporarily in the back end so that it doesn't need to reprocess it every single time you send the query and take a long time. It's got that context cached in the backend inside the LLM, so that once we've stored it once, it's stored in a really efficient way that our LLM can just reference the context that we've stored there. So it makes the ingestion and retrieval a lot simpler than RAG, because all we've got is our large data set, which we ingest into our LLM. So we store it in a cache, and we can do that through something like NAN. It's stored in the context of the LLM temporarily. So whenever somebody asks a question, and if we ask 10 questions, it's going to use everything it's already got, but also all of the context from the backend. So the benefits here are it's easy to set up, it's very quick to retrieve from, and it's more accurate because it's got the full context. Versus RAG, where we're pulling the 5 most similar bits of information, it doesn't always get it right. However, some of the issues with CAG, for example, when we're using it in a business context, is it's harder to update it because we've got to update a large document store, but also it's not suitable for an extremely large set of knowledge. We've still got to store that in the context window of our LLM. So if we're surpassing the token limit still, it's not going to work. Now, RAG or CAG, which one should you use for your business? And how do you actually implement these so that you can give your AI context and your business context? Well, we're going to cover that in an entirely separate video, as well as some of the ways in which we can enhance the quality of the retrieval of these different methods to make sure that when we're pulling information, we're pulling the most accurate information. If you enjoyed this video and you're looking for more information around how to implement AI within your business, then head to school.com/scrapes and like and subscribe the video. Thanks so much for watching.